Welcome to Demystifying Math. In this lesson, we're going to be finding formulas for the apparent nth term of arithmetic and geometric sequences. A sequence is considered to be arithmetic if there is a constant difference between the terms of the sequence. Let's start with this example. We have the sequence that starts at 2 and then goes to 5, 8, 11, 14, 17, and so on. There is a difference of 3 between the terms of the sequence. In other words, if you start at 2 and you add 3, you get 5, add 3, you get 8, add 3, you get 11, and so on. If a sequence has a common difference, then there is a linear relationship between the set of natural numbers and the terms of the sequence. And the formula for the arithmetic sequence would be a subscript n equals a, the first term of the sequence, plus d, the common difference, times n minus 1. You can write the terms of the sequence as ordered pairs, where the domain is a set of natural numbers, and the range contains the numbers in the sequence. So that would be of the form n comma a sub n, where n is the set of natural numbers. Remember, the natural numbers start at 1 and then go 2, 3, 4, and so on. And an is the value of the term of the sequence. So in this case, we have ordered pairs like 1, 2, meaning that the first term has a value of 2. 2, 5, meaning the second term has a value of 5. 3, 8, 4, 11, and so on. You can think of your common difference just like you thought of a slope, because this is a linear relationship. So we can take our ordered pairs and plug them into our slope formula to find our common difference. So our normal slope formula is y2 minus y1 over x2 minus x1. Well, in this case, we're calling it a2 and a1 instead of y2 and y1. And our n values are 2 and 1. So we have 5 minus 2 in our numerator and 2 minus 1 in our denominator, giving us a common difference of 3. Now we also need to know the first term of the sequence in order to write the formula. In this case, it was given as 2. So plugging into our general formula, our a value is 2 and our d value is 3. So we have 2 plus 3 times n minus 1, which I will simplify down to 3n minus 1. And I distributed the 3 and combined like terms. Now you always want to check and see if you did it correctly. So we also know that the fifth term has a value of 14. So if we plug a 5 into our formula, we should get out 14. So using the 3n minus 1, we're going to replace n with 5. So we have 3 times 5 minus 1, which gives us 14. So we know that we did this correctly. Now once you find a formula for your sequence, you can find any term of the sequence without having to go back and find all the previous terms. So let's find the 10th term of this sequence. We're going to do that by plugging a 10 in for n. So we have 3 times 10 minus 1, or 29. 29 would be the value of the 10th term of the sequence. So sometimes you're not given the first term, and you're not given enough to find the difference between two consecutive terms. In this case, we're given the 5th term and the 10th term. And we want to be able to find a formula for the sequence and at least be able to find the first term of the sequence. So what we're going to do is use our slope formula to find the d value. So in this case, we have 2 ordered pairs. The 5th term is 18 and the 10th term is 43. So we're going to subtract our y values, or a values in this case, and we have 43 minus 18, and our n values are 10 and 5. So we end up with 25 over 5, or a common difference of 5. Now we still have to find a. So we're going to plug in what we just found, which was our common difference, d, which was 5, and one of the ordered pairs. So we're using the 5 and 18. So when n is 5, 18 is our an. And then we plugged it in and simplified. So we have 5 times 5 minus 1, which gave us 5 times 4, or 20. And then subtracting the 20 from both sides of the equation to isolate a, we get a is negative 2. So that means that our formula is negative 2 plus 5 times n minus 1. Then distributing the 5 and combining like terms, we get 5n minus 7. Of course, you always want to check your work. So we also know that the 10th term has a value of 43. So if we plug 10 into the 5n minus 7, we should get out 43. And in this case we did, so we know that we did our work correctly. Okay, let's talk about geometric sequences for a few minutes. If you have a geometric sequence, that means that there's a constant ratio between the terms of the sequence. Let's look at this example. We have 3, 6, 12, 24, 48, and 96. You can find the constant ratio by dividing one term by the previous term. So 6 divided by 3 is the same as 12 divided by 6, which is the same as 24 divided by 12, and they all equal 2. So our constant ratio is 2. If you have a constant ratio or a common ratio between the terms of the sequence, then you have an exponential relationship between the set of natural numbers and the terms of the sequence. And that exponential ratio will be of the form g subscript n equals g times r to the n minus 1, where we're letting g equal the first term of the sequence and r being the constant ratio. In this case, our r value was 2 and our g value was 3, so the formula will be 3 times 2 to the n minus 1. Again, you want to check your work. So we also know that the fourth term has a value of 24. So if we plug in 4 for n, we should get out 24. So remember that we're going to subtract 1 from our exponent. So we put the 4 in for n in the exponent and reduced it by 1 to get 3. 2 to the third is 8 times our first term, which is 3, which gives us 24. So we know that we've done this formula correctly. Now, just like we did with the arithmetic sequences, we're not always given the first term and we're not always given the common ratio. In this case, we have to figure out both. And we're going to do that by setting up a system of equations. So in this case, we're given that the fifth term has a value of 3/16 and the eighth term has a value of 3 over 128. So plugging into our formula, we plugged in the 5 for n and reduced it by 1 to get 4 for our exponent. And our output value is 3/16. So what we're going to do is isolate g. So we're dividing both sides by r to the fourth. Then we're going to do the same thing with the other ordered pair. We're going to set that equation up. So again, I reduced the exponent by 1, so we have r to the 7th, and our output is 3 over 128. Then what I did was I brought the value of g from the first equation over to the second equation. Now you see we have r to the 7th over r to the 4th, so that can be reduced to r to the 3rd. And then we bring the 3/16 over to the other side, multiplying by the reciprocal. And then reducing our fractions, we get 1/8 equals r to the 3rd. Now we want to isolate r, so we're going to take the cube root of both sides of the equation. So the cube root of 1/8 is 1/2. So our r value is 1/2. So we found r, now we have to go back and find g. So we're going to go back over here and grab this equation and plug in the r value. So we now have 16 times 1/2 to the 4th. Well, 1/2 to the 4th is 1/16. So if you multiply that by 16, you get 1. So our g value is 3, which means that our formula is 3 times 1/2 to the n minus 1. Now again, you want to check your work, so you want to look for the 8th term having a value of 3 over 128. So plugging in 8 and subtracting 1 from your exponent, you get 1/2 to the 7th, which is 1 over 128, and then multiplying by 3, we get 3 over 128. So we know that we found this formula correctly as well. And now that you have the formula, you can go back and find the first term, the third term, whatever term that you need for your sequence. Okay, thank you for tuning in to Demystifying Math.